Next is question number 66, which says that the angle between the pair of tangents drawn from the point 1 by root 2, 1 by root 3 to the ellipse 3x square plus 2y square equal to 1 is. Now the ellipse that is given is x square upon 1 by 3 plus y square upon 1 by 2 equal to 1. This is the equation of the ellipse. So we can find the equation of director circle of this ellipse as x square plus y square equal to a square plus b square, that is 1 by 3 plus 1 by 2. That is, the equation of director circle is x square plus y square equal to 5 upon 6. Now students, here we can observe that the given point, that is 1 upon root 2, 1 upon root 3 is lying on the director circle of this ellipse, because 1 by root 2 whole square plus 1 by root 3 whole square is equal to 1 by 3 plus 1 by 2, that is again equal to 5 by 6. So the point is lying on the director circle. Now we know that the angle between the pair of tangents drawn from any point on the director circle to the ellipse is pi by 2. Hence the correct answer will be option number 4. Next is question number 67, which says that the equation of focal chord of y square equal to 4x inclined at angle 45 degree in anti-clockwise direction with its axis is. Now for a line inclined at 45 degree to positive x-axis, we can say that its slope will be equal to tan of 45, that is 1. So the slope of the line is equal to 1. Now as the equation is a focal chord, so it must be passing through the focus. Now the focus of the parabola y square equal to 4x is a comma 0, that is 1 comma 0. Hence the equation is passing from the point 1 comma 0. So the equation of focal chord can be written as y minus y1 is equal to m into x minus x1, that is 1. Hence the equation is y equal to x minus 1, that is x minus y is equal to 1. That is, the correct answer will be option number 2. Next is question number 68, which says that if the foci of an ellipse are S 2, 3 and S dash, that is 3, 2, and one of its vertices is V, that is 4, 1, then the length of the lattice rectum is, let us say this is the ellipse whose foci are 3, 2 and 2, 3, and one of the vertices is 4, 1. Now we know that the distance between the foci is equal to 2AE, so this will be equal to under root of 3 minus 2 whole square, that is 1, plus 2 minus 3 whole square, that is again 1. So this is equal to under root 2. Hence the value of AE is equal to root 2 upon 2, that is 1 upon under root 2. Now the center of ellipse, let us say C, will be equal to the midpoint of the foci. So it will be equal to 3 plus 2, that is 5 upon 2, comma 3 plus 2, that is 5 upon 2. So this is the center of the circle. So we can find the value of A is equal to, that is the distance between C and let us say this is the point V, that is 4, 1. So the length A will be equal to 5 by 2 minus 4 whole square plus 5 by 2 minus 1 whole square. So this will be equal to under root 9 upon 4 plus again 9 by 4. So this will be equal to 3 upon 2 into root 2. So this is the value of A from here. Now we know that B square is equal to A square into 1 minus E square. So this will be equal to A square, that is 9 upon 4 into 2 minus A square E square, that is equal to 1 upon 2. So this is equal to 8 upon 2, that is 4. Hence the value of B is equal to 2. Now the length of lattice rectum will be equal to 2B square upon A. So this will be equal to 2 into B square, that is 4 upon A, that is 3 root 2 upon 2. So this is equal to 8 upon 3 into root 2. That is, the correct answer is option number 1. Next is question number 69, which says that the area of the quadrilateral formed by two pairs of lines x square minus xy minus 6y square equal to 0 and x square minus xy minus 6y square plus 5y minus 1 equal to 0 is. Now to find the area of quadrilateral, we have to find individually all the straight lines. Now firstly, let's start with this pair of straight lines. Dividing by x square, we will get 1 minus y upon x minus 6 into y upon x whole square is equal to 0. Let us put y upon x equal to t. So we will get 6 into t square plus t minus 1 is equal to 0. So from here we can find t equal to minus b plus minus under root d, that is b square plus 24 upon 2 into a, that is 12. So this is equal to minus 1 plus minus 5 upon 12, which is equal to 4 upon 12, that is 1 by 3, comma minus 6 upon 12, that is minus 1 upon 2. That is the value of y is equal to 1 by 3 into x and y is equal to minus 1 by 2 into x. Hence straight lines are 3y minus x equal to 0 and 2y plus x equal to 0. Similarly, to find the pair of straight lines of this, let us compare this straight of lines with x plus ay plus b into x plus cy plus d equal to 0. The coefficient of x, y as c plus a. So c plus a and the coefficient of x as d plus b, and the coefficient of y will be equal to a, d plus b, c. Similarly, we can find the coefficient of y square as ac and the value of constant, that is bd, is equal to minus 1. So similarly, we can say that c plus a is equal to minus 1, b plus d is equal to coefficient of x, this is equal to 0, and a, d plus bc, that is coefficient of y is equal to 5, and ac is equal to minus 6 and bd is equal to minus 1. So solving these equations, we can find the values of a, b, c and d, and we can find that the pair of straight lines are x plus 2y minus 1 equal to 0 and x minus 3y plus 1 equal to 0. So these are the four pair of straight lines. So we can see that these two straight lines are parallel and these two pair of straight lines are also parallel. So this is a parallelogram. Let us say this is x plus 2y equal to 0 and this is x plus 2y minus 1 equal to 0, and this line is x minus 3y equal to 0 and this is x minus 3y plus 1 equal to 0. Now for a parallelogram, we know that area is equal to P1 P2 into cosecant theta, where the value of P1 will be equal to the distance between these two parallel lines. So this will be equal to 1 upon under root 5. Similarly, the value of P2 will be equal to 1 upon under root 3 whole square plus 1 whole square, that is 10. Now we have to find the value of cosecant theta. For that, let us find the value of tan theta between the two lines, which will be equal to m1. That is m1 will be equal to minus coefficient of x upon coefficient of y, that is minus 1 by 2. And for this, m2 will be equal to 1 upon 3. So tan theta is equal to minus 1 by 2 minus 1 by 3 upon 1 minus 1 upon 6. Modulus of this will be equal to 5 upon 6 upon 5 upon 6. So this is equal to 1. That is theta is equal to pi by 4. Hence the value of cosecant theta will be equal to root 2. Hence the value of area of the quadrilateral will be equal to 1 by root 5 into 1 upon root 10 into under root 2. So this is equal to under root 2 upon under root of 50, that is 25 into 2, that is we can take 5 common, so this will be equal to 1 upon 5 square units. So the correct answer will be option number 4. Next is question number 70, which says that the number of double ordinates of the hyperbola x square upon a square plus b square minus y square upon 2ab equal to 1 which subtends right angle at its center is. So let us say this is the coordinate axis and this is the hyperbola. Let us say this is the double ordinate AB and it subtends right angle at the center, that is here. Let us say this point is O. So in triangle OAM and triangle OBM, we can see that as this is a double ordinate AB, so this length AM will be equal to BM and OM is common and also OA is equal to OB. So these two triangles are similar. So we can say that this angle will be equal to this angle. So the angle MOA is equal to pi by 4. Now as this angle is pi by 4, so we can say that AM is equal to OM. Hence the coordinate A can be taken as x1, x1, right? Now as this point is satisfying the hyperbola, so we can say that x1 square upon a square plus b square minus x1 square upon 2ab is equal to 1. That is, taking x1 square common, we can say that a square plus b square into 2ab minus a square plus b square is equal to 1. That is, the value of x1 square is equal to a square plus b square into 2ab upon 2ab minus a square plus b square. That is, taking minus common, we can write it as a minus b whole square. Now here in the question it is given that a and b are greater than 0. So we know that a square plus b square is greater than 0 and 2ab is greater than 0. Also a minus b whole square is greater than 0. So the quantity in the right hand side is negative due to this minus sign and the quantity on the left hand side is positive because x1 square is always greater than equal to 0. So there is no solution for x1, right? So we can say that the number of double ordinates which subtends right angle at its center is 0. So the correct answer will be option number 1.